Hello friends, I am Professor Shubham from Department of Mathematics, Joshi College, Hadapsar. This is our 7th lecture on limit and continuity. Limit and continuity. In this lecture, we are discussing about the continuity. But now, firstly we see the example. Example second. Example 1 are seen in last lecture. But example 2 is let evaluate limit as xy tends to 0 0 sine of x square plus y square divided by x square plus y square x square plus y square. Solution. Let firstly we change the x is equal to r cos theta and y is equal to r sin theta. That is, in the polar form x is equal to r cos theta and y is equal to r sin theta. Then we know that if xy tends to 0 0, xy tends to 0 0, then r tends to 0 plus, then r tends to 0 plus. Therefore we have limit as xy tends to 0 0 sine of x square plus y square upon x square plus y square is equal to limit as r tends to 0 plus sine of r square upon r square, because if x is equal to r cos theta and y is equal to r sin theta, then r square plus x square plus y square is a r square. Okay. Now we know that if sin a upon a, limit as a tends to 0 sin a upon a is 1, so we have an answer. Therefore limit as xy tends to 0 0, xy tends to 0 0 sine of x square plus y square upon x square plus y square is okay is equal to. Now the next point is continuity. What is the continuity? Continuity of a function of two variables. In simple words, if the graph of function is continuous, then this function is said to be continuous function, and if graph of function is a break from some point, then this function is said to be discontinuous at this point. Okay. Now, firstly we discussed the continuous function of two variables. Let f be a function of two variables. Let f be a function of two variables x and y, in a domain D, and AB belongs to D is a subset of R square, and AB belongs to D is a subset of R square, then this function f is said to be continuous if limit as xy tends to AB, f of xy is equal to If this condition is satisfied, then this function f is said to be continuous at point A. Okay, that is in other words, if xy tends to AB, then f of xy tends to f of म्हणजे ज्या वेळेला xy AB ला होतो त्याला f of xy कुठे गेला म्हणजे f of AB ला that is the distance between xy and AB is small, then the distance between f of xy and f of AB is very small. Okay, so now we discuss the definition of continuity in the epsilon delta form. That is, let f be a function of two variables in a D and AB belongs to D is a subset of R square, then f is said to be continuous. F is said to be continuous if for every if for every epsilon greater than 0, if for every epsilon greater than 0 there exists correspondence delta greater than 0, there exists correspondence delta greater than 0 such that f of xy minus f of AB in a modulus is a less than epsilon whenever under root of x minus a bracket square plus y minus b bracket square is less than delta. That is, if the distance between x and y is very small, that is less than delta, then the distance between f of xy and f of ab is very small. Then this function f is said to be continuous at point A. Okay. It means that if xy belongs to AB, that is, if distance between x and xy and AB is a very small, then f of xy goes to f of AB. That is, the distance between f of xy and f of AB is very small. That is, for every epsilon greater than 0, there exists a delta. That is, if delta depends on the epsilon. Okay. Now. Next point is the geometric interpretation of curve. The continuity says that if xy approaches to AB, if xy approaches to AB means xy very small, xy changes very small amount, then f of xy also changes in the very small amount. That is, the function f is continuous if the surface that is the graph of function is continuous, that is, it has no any hole or breaking point, that is the break of the surface. Okay, this is the geometrical interpretation of the continuity. Geometrical interpretation means the function in the geometric. Okay, a function is said to be continuous if its graph is continuous or it has no any hole or a break. Okay, now we discuss the continuous function of three variables. Continuous function of three variables. Let f is a function of xyz, that is three variable f is a function of xyz in on a domain D and ABC belongs to D, which is subset of RQ, then the function f of xyz is continuous at ABC if limit as xyz tends to ABC, f of xyz is equal to f of a dx. It means that if xyz tends to ABC, if xyz tends to ABC, then f of xyz tends to f of x. That is, if tuple xyz tends to ABC, then f of xyz tends to f of a. Then this function is said to be continuous of three variables. That is, in the epsilon delta form, if epsilon greater than 0, there exists correspondence delta greater than 0. If under root of x minus a bracket square plus y minus b bracket square plus z minus c bracket square is a less than delta, then mod of f of x y z minus f of a b c modulus of f of x y z minus f of a b c is less than, and the delta depends on the epsilon. This definition is same as continuous function of two variable. Here only change the z and c are the included in the continuous function of the three variable. Okay. Now, next properties of continuous function. Now, the properties of continuous function. Now, we also know the property of continuous function. In our variable, let f of xy and g of xy are the continuous function at point AB or on a set D on D is subset of R square. If f of xi and g of xy are the continuous function on D is a subset of R square, then f plus g is continuous on D. F plus g is continuous. That is, addition of two continuous function is again a continuous. Also, subtraction of two continuous function is again a continuous. Okay. At point AB on at AB where at AB belongs to D square. Then f plus minus g is continuous at point AB. Second one is also scalar multiplication, that is constant into function, is also continuous at point AB. That is plus minus f plus minus g is also continuous. That is, addition of two continuous function is continuous. Scalar multiplication of continuous function is again a continuous. Also, multiplication of two continuous function is again a continuous. Fourth one is a division of two continuous function is again continuous at AB, but here only one condition: g of AB is not equal to 0. g of AB is not equal to 0. That is, if denominator is not equal to 0. Next, if f is continuous, then mod f is also continuous at point A. Mod f is also continuous at point A. Okay, these are the properties of continuous function. First is if f and g are continuous function at point AB, then addition of continuous function is again continuous. Also subtraction is again continuous. Scalar multiplication is continuous. Multiplication of two continuous function is again continuous. Division of two continuous function is again continuous. And last one is if f is continuous, then its modulus is also continuous at point A. Okay. Next point is the continuity of composite. Composite function is denoted by G composition type. That is, if f is a function from function AB to something, f is operates on AB, and G is operates on f of AB, then we can say that G composition f of AB. It means that G composition f of AB is equal to G of f of. Now, for finding the continuity of composite function, we have let f be the function of with a continuous function as AB belongs to D. If f is a continuous function and AB belongs to D is a subset of R squared, and G is also continuous. G is continuous at f of AB. G is continuous at image of AB. Then G composition F is continuous at point A. Okay. Now the next theorem is this is the continuity of composite function. Next one is the theorem. If f of xy is continuous and point AB belongs to D, is a subset of R square. If f of xy is continuous at point AB belongs to D, is subset of R square, then f of xb is continuous at f of xb is continuous at x is equal to a, and also f of ay is continuous at y is equal to. That means if f of xy is continuous at AB, if it replace y by b, then the function f of xb is continuous at x is equal to a, and also f of ay is continuous at point y is equal to b. Okay. Now, next one is the example. Evaluate limit as xy tends to 1 to x cube plus y cube plus x plus 5 plus 2. This is continuous function, and here xy tends to 1 to xy tends to 1 to. Therefore, this is solved by direct method, that is direct putting of the values, that is 1 cube plus 2 cube plus 1 plus 2 plus 2 is equal to 1 plus 8 plus 1 plus 2 plus 2 is 8, 9, 10, 12, 14. Answer is a 40. Okay. Now we will discuss the next example is where the function f of x y is equal to x square minus y square upon x square plus y square is x square minus y square upon x square plus y square is continuous. Also, we have a question where the function f of x square minus y square upon x square plus y square is discontinuous. Also, we find the discontinuity and continuity of the function. Okay, now let f of xy is equal to x square minus y square upon x square plus y square. We know that f of xy is a rational function of two polynomials, and we know that polynomial function is always continuous. Therefore, here f of xy is equal to h of xy upon g of xy. H of xy upon g of xy, that is h of xy is equal to x square minus y square, but this is a polynomial function, is continuous, it's always continuous, and also g of xy is equal to x square plus y square is also always continuous because is it a polynomial function. Okay, now we have to check. We know that if h is continuous, g is continuous, then h upon g is also continuous, provided the denominator is not equal to 0. Therefore, f of xy is continuous. Therefore, f of xy is equal to h of xy upon g of xy is continuous by the property 4 is continuous, provided that is we have a condition g of xy is not equal to 0. Okay, that is g of xy is a x square plus y square is not equal to 0. Okay. Only this condition is exceptional cases. Now x square plus y square is equal to 0, then this implies we have two positive number and its addition is 0, then both are also 0. Therefore, x is equal to 0 and y is equal to 0. Therefore, we have expression case only the point 0, 0. Therefore, D is a xy belongs to R square such that xy is not equal to 0. This is the domain in which f of xy is equal to x square minus y square upon x square plus y square is continuous. ओके, म्हणजे याच्यामध्ये काय केलं बघा, आपण डिस्कंटिन्यूटी चेक करतोय. कंटिन्यूटी पूर्ण d वरती आहे, पण फक्त एकच गोष्ट आहे काय तर डिनॉमिनेटर आपला कधीही 0 नसतो. डिनॉमिनेटर if denominator is 0 then function is not defined, therefore limit does not exist. Okay, now we get the denominator is not equal to 0, that is x square plus y square is not equal to 0. Now if x square plus y square is equal to 0, then x is equal to 0 and y is equal to 0. Therefore we have a condition d is equal to xy belongs to r square such that x square plus y square is not equal to 0, that is d is equal to set containing xy belongs to r square such that xy is not equal to 0, 0. xy is not equal to 0 0. This have another answer is this function f of x1 is discontinuous at only point 0. This function is discontinuous at only point 0. Okay. Now, example. Now we see the next example is discuss the continuity of f of x, y, z is equal to 1 upon x square plus y square plus z square minus. Also, in this question, we have f of xyz is a rational function of two polynomials. That is, one is 1 and second is two polynomials. H of xy is equal to 1 and g of xyz, h of xyz is equal to 1 is constant, and constant function is always continuous, and g of xyz is equal to x square plus y square plus z square minus 1 is also polynomial function, and polynomial function is continuous at any point. Therefore f of xyz is equal to 1 upon x square plus y square plus z square minus 1 is continuous provided but we have only one condition is denominator is not equal to 0, that is x square plus y square plus z square minus 1 is not equal to 0. If it is equal to 0, x square plus y square plus z square minus 1 is equal to 0, then this implies x square plus y square plus z square is equal to 1. Therefore f is continuous. F is continuous on whole r square but not in the surface of not on the surface of sphere x square plus y square plus z square is equal to, that is, sphere centered at origin with radius 1. This is continuous overall the r square but not in the sphere centered at origin and radius is 1. This is the discontinuous one. Therefore, b is equal to xyz belongs to R cube. xyz belongs to R cube, but x square plus y square plus z square is not equal to. This is only condition is continuity. Okay. म्हणजे फक्त या कंडिशनला डिस्कंटिन्युटी आपल्याला मिळणार आहे, बाकी सगळ्या कंडिशनला काय म्हणतात, फंक्शन इज कंटिन्यूअस. ओके. Now we will stop here. Thank you for watching this video. Thank you very much. And our first chapter is over.